Hi there guys, a fellow member actually asked for my experience with this tool, which I did not really use, but I started to browse around a little bit and I even contacted one of the founders. Um, and I think it's great because this guy actually asked me how to use this tool in a solar energy suitability analysis. And believe it or not, there actually is a workflow tool in here. So we can actually run a solar energy analysis. So let's start off. We have a data set with potential solar farms, which I drew using this tool right here. So you can just click here, start drawing a polygon, and immediately it will create a layer for you, which you can then call potential solar farms, right? So maybe you even have a data set that you could upload right here, and you could just upload a shapefile or a GeoJSON file, and you already have those locations. Otherwise, you can just draw and pretty much just drawing polygons for potential locations. So I just drew him up right now just to give you an example. And I also added a solar farm layer, but this is a very big data set, so it takes some time. However, this is in the Atlas Data Hub, where you can actually find this data and much more data as well. So to find the potential locations, you may want to add in more data as well, because you can add buildings, parks, land cover, because, well, from there you will find that most of the land surface will not be suitable for solar panels, I assume, because a lot maybe protected parks. Well, a protected park is not going to be suitable for solar energy. Water bodies, that will be pretty hard to do. And well, there's much more data that you could use, like roads. You won't put solar panels on roads or maybe on buildings, but if we are looking at just farms right now, then that may not be relevant. However, you could even run another analysis on the buildings to find the suitability of solar panels on buildings as well. Either way, I would suggest you use this land cover, the parks, the buildings layer, and the existing solar farms layer as well, and then try to find potential locations from there. Additionally, one more layer that you should use is a layer from the grid, because you want to use the grid to find out which locations you can even connect the solar farm to in the first place, right? Because maybe somewhere in the middle of the desert, it may take a lot of infrastructure to even be able to put a potential solar farm there. So make sure to take that into account as well. Or maybe the grid is completely congested, so then it doesn't make much sense to use or place any solar farm, because, well, in that case, there is just no room for the grid to even use that solar energy. However, forgetting about that, this is what we can do, because, well, I don't have the data in here right now, but I'm sure you can find it. We have solar energy analysis as a tool in this toolbox on this application. We use that as the polygons in the map. So let's start off with selecting this polygon right here. We could select all of the polygons, or we could say, and just select the layer as a whole. In this case, we just have one polygon, so it doesn't really matter. And you could also select exclusion zones. However, if you just use this data set and only select the polygons in this data set, you don't have to do that. You can use different templates, which are like the distribution of the solar panels. I'll just use this right now. You can also use your own template, because, well, these are common distributions of solar panels within an area. Maybe for you it's completely different, or you want to use a different distribution. And you can also play around with the tilt and the tracking and the angle between the horizontal plane and the direction of the panels, so the way that they are facing. Or just click optimize so that it immediately selects the greatest tilt and azimuth. I don't know if I'm pronouncing that correctly, I'm not familiar with that term, but it will automatically optimize it for you. You can choose different dimensions as well, so let's say this structural spacing, row clearance. You can play around with those, and you can play around with those configurations as well. And energy production, you can choose different panel types. I assume you would use the most common or ultra high or premium high ones at this point, because, well, preferably or most realistically, you would use those if you was to indeed place a potential solar farm somewhere. And you could also use the AC/DC ratio or like the system loss in here as well. So there's 12% energy that is lost over the total percentage of the energy. I think that ties into just the default value, so you can change that around. Anyways, we can now run this analysis. And right here, it will show us the results. So we have 402 panels that are placed right here, which is not that much. At least it doesn't look like it's that much the way it's placed right now. And the ground coverage ratio is 0.09, which is 9%, which is not that great. So in other words, 9%, no, like the ratio between the actual solar panels and the ground is 9% or 0.09. Sorry, I didn't word that correctly. However, you understand what I'm saying. Right here, we can open the report or save the layout as a data set. Either way, we open the report, and right here we have the exact amount of energy that this solar farm would generate for us and the amount of loss per month with a graph as well. And you can download this as an image or CSV. So yeah, I feel like this isn't just literally your research or literally just all you need to have. What you do want to take into account is the actual capacity that the grid holds, because obviously it's just not going to be able to use all of this energy at any given moment. If the grid is congested already, if it can hold far more energy, then obviously this is going to be valuable. But you may want to take that into account, at least in the discussion. However, this is just how you use it practically. If you want to dive into the more theoretical side of things, I would love to get on a call with you as well. But this is just all that you have to know on the practical level. And if you actually uploaded this data set with solar farms as well, maybe you could just get that solar farm data set in QGIS using the Quick OSM plugin. You could download the OpenStreetMap data regarding solar panels or farms for just the eastern province of Saudi Arabia, which won't take as long as my case, where I am currently doing it for the entire world, which is not great. But yeah, I cannot filter it right now. Anyways, I hope that's been valuable to you, that you actually understand how to use this and what I'm talking about. Regardless, you could also take into account wind energy, solar or shade analysis, and whatnot. You could even take into account soil types. You could take into account land cover. So yeah, I think you can find a lot of with this, but this tool is going to be very useful for you. So that's all that I wanted to show to you. I hope it's been valuable, and I'll see you in the next video.